Quality Control and Improvement, Module 3, Lecture 4.
So looking at objectives for Lecture 2, we're going to look at different statistical tools needed to quantify and describe and detect process variation. In the last lecture, we looked at one of the major ones, which was the control chart. Now we're going to look at some other ones that can also be very useful. Reading assignment was Chapter 5, pages 175 to 217. So statistical process control can be applied to any process. Its 7 major tools are the control chart, which we've looked at in the last lecture, the histogram, the check sheet, the Pareto chart, the cause and effect diagram, defect concentration diagram, and the scatter diagram. So in this lecture, we're going to look at numbers 2 through 7. One of the most useful one, is the control chart, but the next one I would say that's also very useful is the histogram. This chart shows you kind of why I love Minitab, because the information you can get from histogram with all the different options is really incredible. First of all, so here we plot some data. We plotted 40 data set of 40. We can get the mean. We can get the variance. We can also plot fit it to a normal distribution, so we can sort of see what a normal distribution would look like, and this looked pretty good. Looking at it looks like it's pretty normal to me, but we'll also be able to tell that from Minitab will also give us a good indication of that. It also plots the box chart down below. We can see, when we talked about box charts, it plots the box chart for you. It gives you the 95% confidence intervals for the mean and the median. So up here at the top, it does what's known as the Anderson-Darling normality test, and so this is actually a test that tells you how your data fits to a normal curve. And so the one I always look at is the p-value here. If this p-value is greater than 0.05, that indicates that to me that it's fairly normal. I mean, statisticians would say that it fails to reject the null hypothesis, so you cannot conclude that the data do not follow a normal distribution. Layman's terms, if this is greater than 0.05, you can conclude that your data is fairly normal. And it also plots for the box charts, it plots the minimum, the maximum, the median, the first quartile, third quartile, 95% confidence intervals. So a lot of stuff you can tell from a standard histogram. Another useful diagnosis tool is what's known as the check sheet. And especially in the early stages of process improvement, it often becomes necessary to collect either historical or current operating data about the process under investigation. So here, basically, what you do is that this is 1 through 12 months for years 2002 and 2003. You sort of for January here, you sort of list off what possible defects occurred here. You know what I mean? So you have January, you had 2 cases where you have a misaligned well, and 2 cases where the processing was out of order. For February, same kind of thing. And so this gives you sort of running total. You can sort of look back and you can see some history of this. You have some kind of reoccurring things happening all the time here, like this parts damage. I mean, this occurs a lot. Look at this October thing here. You had 10 of these. I mean, so you can sort of get a lot of useful information here, and it's very useful in that measure step of the DMAIC. Another one that's used a lot is what's known as the Pareto chart. It's simply a frequency distribution or histogram of the attribute data arranged by category. So in this case, you would list like it's similar to the other chart, but here you kind of plot a histogram of it. So you had 36 instances of incorrect dimensions. You know what I mean? And 34 cases of parts damage. So you can sort of use the previous chart and make a Pareto chart out of that and graph what the frequency is. It sort of gives you, what's the most what's happened, what happened most here that causes problems. Pareto charts are useful, and again, in the measure and analyze stages of DMAIC. Another very useful chart is what's known as the cause and effect diagram. Once a defect, error, or problem has been identified either by the Pareto chart or one of the other methods, you need to analyzed for further study and figure out what's actually causing it. In situations where the causes are not obvious, the cause and effect diagram is a formal tool frequently used in finding potential causes. So this is again is useful in the analyze and improve steps of the bank. The steps that can construct the cause and effect diagram our book lays out. First you want to define the problem or effect to be analyzed. Usually you form a team to perform the analysis. Often the team will uncover potential causes through brainstorming. They'll just sit around and talk about, what do we think causing the problem here. Then what they'll do is they'll draw what's known as the effect box and center line. So they'll draw this center line and they'll list what the defect, defects on tanks. That's our problem. So they'll identify the possible causes and they'll classify them in the categories. So for example, is the machines the problem? Is the materials the problem? Is the methods we're using? Is the measurement doing something different in measurement? Is the personnel our problem? Then they'll create new categories, if necessary. And then off of each of these problems, they'll list what could cause it. So in machines, maybe it's a worn tool, or it's too much play, or it's the wrong tool, or there's dust in it, etc. For like methods, is it wrong work? Is the planning wrong, or is the materials handling? We doing something wrong with that? Personnel, is it inadequate supervision causing the problem? Is it insufficient training, poor attitude, etc. So these gives you kind of a big flow chart that you can kind of try to figure out exactly what's going wrong with your process. And then once you lay this chart out, you want to rank the order of causes to identify those that seem likely to impact the problem, and then you want to take corrective action. You may list this, okay, this is our number one problem right here, and this maybe over here is our number two problem, and then you can start working on these at number one and start honing in on exactly how to fix this problem. Another chart that's often used is what's known as a defect concentration diagram. This is actually a kind of like a three-dimensional view laid out on a two-dimensional chart. It shows all kind of relevant views. So, for example, if this was a car, you would have the front. This is like a refrigerator, but so this is a refrigerator. You have the front of the refrigerator, the top of the refrigerator, the left side, the right side, back side, bottom of the refrigerator, and then you list your defects on the actual diagrams. If you got paint problems, you can sort of indicate where it occurred at. These are very useful to if you have a location problem. The defects are only occurring on certain places. This can be very useful as well. The next one is what's known as the scatter diagram. This is useful for plotting and identifying a potential relationship between two variables. So here, for example, again, I got this out of the book. It says reclaimed flux and metal recovery. It could be, height and weight or whatever. You got two variables you want to plot. You want to see how they relate. The problem with this is that, often you can be misleading. You can run into the problem of, correlation and causation. Just because something is correlated doesn't mean it implies causation. That's a problem with the scatter chart. I mean, this here is a classic example where you plot, total U.S. highway fatalities against fresh lemons imported to USA from Mexico. You know what I mean? And so you can get these kind of weird relationships where it looks like, that, oh my gosh, in 1996, we imported a lot of lemons, and down here in 2000 we didn't import many, and we didn't have as many accidents. So it looks like that, that there's a relationship between highway deaths and the number of lemons we're importing from Mexico. So it's kind of, you can get into these kind of this plots on a straight line. So this is mathematically this makes sense, right? But the problem is that just because something is correlated like this doesn't mean one causes the other. It could just be happenstance, right? So you have to be real careful with scatter diagrams. And okay, so that's the end of this module, and so we'll launch into the next module and start looking specifically at control charts for variables.